Hi again. Been up here recently to say some things about Git tonight. Not actually entirely sure how this will play out. I just have a few notes here. I should ask first, who's heard of Git in the room? Who's used Git? Who gets confused and scared by Git? Okay. So see what I can do about that. It's one of these systems where it makes a lot more sense once you understand the underlying concepts, I hope. So pretty much everyone's heard of it. But Git is a distributed version control system. It's a version control system in that it will track multiple versions of some set of content, like the source code for a program, and let you manipulate those and compare those in all sorts of interesting ways. Git is also distributed in that everywhere that you're working with this content, you have a copy of the entire repository, that set of versions and differences between versions of the code. And so then there are protocols for these different repositories to talk to each other and exchange data and things like that. And this is in contrast to sort of the previous generation of centralized version control systems. Subversion is popular, where there's only one copy of the repository on a central server, and to do anything with it, you have to talk to that server, which is a bit simpler, but less flexible. I think that's that. History lesson for the day. Git showed up in 2005, originally hacked together by Linus Torvalds for use in the Linux kernel project. And that's still a very large Git repository today, and that was replacing a proprietary version control system that the Linux kernel previously used. What did it previously use? BitKeeper. And then they got into a fight about licensing, and that didn't last very long. 2008, GitHub showed up, which is a very, very popular, actually centralized host for Git repositories. Adds a lot of nice features on top of that for issue tracking and all sorts of things. And so there's a great community of open source software there using Git. I think that's all I have here. Let me see if I can demonstrate a little something with Git. Can I make this bigger? I can make this bigger. Good. Let's start a project. Let's call it example for lack of a better name. Let's remove my old example. And let's make some files here. Huh?
When I make changes, I reject the entire thing.
All right, so we've got some files. Cool. Let's track all this stuff in Git. Yay, I've got a Git repository. Add some files to it. Create a new commit on there. So some magic just happened. What just happened is the interesting question here. So where am I starting with this? So I said git init. Let's see. I had my file system here. Example. I created a README and a source directory with a C file in it. I said git init. I got one more thing in here, which is a directory called .git. There's a bunch of stuff in there. Most of the time, you don't need to care about the particulars of everything in there, but that is the repository holding all our changes to this code and other sorts of things. To start off with, it's pretty much empty. There's nothing interesting in there. All right, so that was git init. I said git add those files, and that added some stuff to a little data structure in the repository called the index, which, if I'm not mistaken, is really just a mapping from names to file contents. So I think I said hello, and this is really just C, and that started with pound include and went on for a while. All right, we got that. All right, next I say git commit, and here things get a little more interesting. Well, not quite yet. Okay, so a lot of what's contained inside the Git repository is a database of objects. Objects of, I think, 4 different types in total. We'll see 3 of them now that contain all sorts of data and whatever. In particular, I say git commit, and I got a new object of type blob for the content of each of these files. So this says hello. I got another blob with my C program in it. And then I got a tree object containing, well, let's see, this is actually a little more interesting. Says README and had a reference down to here. This one actually adds source, which is a reference to I need another tree object, which just has in.c that points there. Okay, still not too fun. We've represented this set of files in 3 different ways so far. Actually, that way is pretty much the same as that way. Okay, but git commit did one more thing. This is more interesting. We now have a commit object. And this has a bunch of stuff in it. It has a message, which is first commit. It has an author to say who wrote that. Has the date I did it, which is now. Also has separately a committer. In this case, and lots of the time, these are the same, but in projects like the Linux kernel, where people submit patches by email, these are 2 different things: the person who wrote the code in the first place and the person who actually added it to the repository. And most of the metadata here. And finally, we have a pointer to a tree, namely that tree right there. Sure, something like that. Okay, we have, yeah.
I just wondered about the blobs, like leaves of the tree. Like, what are they always at the bottom?
Yeah, they.
One tree points to another tree, which.
Yeah, so I believe a tree can point to trees and blobs.
Like, why does like,
blob doesn't contain anything.
Why doesn't
but data.
README have a tree? Why does main.c have a tree, but README doesn't?
Because this is the tree representing the source directory.
Oh, okay, right.
And and it has an entry in it that says main.c is this stuff.
Yeah.
Yeah. Good question. So we've got that. So I drew some arrows. How do the arrows work? It's a fair question. Binary large object? Something like that? Or just random stuff? All right, I did that. So arrows, how do they work? How do we refer to these things? The answer is we take all, let's see, take all this data in here and run it through our magical hash function SHA-1 and get out, no, did it actually tell us? Yeah, sure. So that was 8CE4B something, something, something. 20 bytes, be 40 characters here. And now we can use this string to refer to that particular commit. The hash function is collision resistant, so if someone gives you this hash and you find a commit with that hash, you can be pretty sure same code they meant you to see. In practice, if you want to talk about a commit, an object, to Git, you can specify 3 or 4 characters as long as that's unique. Fairly common practice is to use the first 7 characters, and that's very likely to be unique within a given repository. Actually, we did that. We did a little hash on the contents of all of these, and we can start naming these blobs as EF4 something, and this is random hexadecimal number or something, and the trees, and so then the content of the tree is really main.c is this value. We hash that whole thing. We've got a value for the tree. Now we can hash this whole tree, and this has a tag, has a ID. That will finally go in here before we compute this hash, and then we have an identifier for the commit. Yeah.
Does the pointer from the tree point to the main tree or to the source tree? Because it looks like the arrows.
You are completely right. Yep. Suddenly, my README disappeared. Okay, there's a commit. I can actually use, let's see. Things get more interesting if I make another commit. Let's change that file. And add it again. And now our index is updated with a capital H in there. And I can say second commit. So here I got, let's see, what did I get there? README is still the same. We can reuse that blob. Actually, we couldn't really create a new one, same content, because it would have the same hash. We've got a new blob here that has the C file with a capital H in it. I guess we've got new versions of the trees too that points to this, and the tree that points to this and to this. And we have a second commit object, which has message second commit, and the same author and committer stuff we had before. And it has a tree, which is, let me try and do this right, which is that tree. So now we have two different, okay, we have two different versions of the source, but we're also interested in not just having these different versions, but seeing how things evolved over time and tracking individual changes to the code. So we have one important piece of information here. We have a parent for this commit, which is that commit. The arrows are a mess. And that should be our second commit. Is that making sense so far? Cool. So all right, let's see what else I can do. All right, so it's probably clear from this that the command line interface of Git is organized around a bunch of these subcommands. Add, commit, init we've seen so far. There are all sorts of those that do different things and have different forms that mean completely different things. But lots of them are really useful. We start a little list back here. We saw init and add and commit. Anyone know some more? Push.
Fetch, checkout, clone, branch.
Yeah.
There's a very extensive list. Diff and reset.
All right, I'm sure I missed some there. Reflog. Reflog. Wait, what did I miss? There were actually some good. Huh?
That's a parameter commit. Git commit dash commit.
Yes.
Okay.
Log. Did I miss log? Okay. Log and stash was out there. Cherry pick is good. Checkout.
Revert.
Yes.
RM.
Sure. RM. MV. Did I have anything? Said branch.
We already have branch.
Do we?
Yes. Right below merge.
Yeah.
Oh yeah. I missed it. Okay. Remote. Status. Config. Well, we're at it.
So that's dash config.
Wait, do you have config already?
I just got that. Yeah. Git config.
It's git dash config.
No. We have revert.
It's git dash.
Git tab. Yeah, it is. That.
Oh, git blame.
Oh, okay, blame. Blame is good. No, merge tool is cool. Merge tool is open your merge in, vimdiff or something and do your merge.
But edit the files.
Yeah.
Edit the files are lost. For the naive users, which one of these are the most important? How do they help
multiple people work.
The first like 5. The first 5, you'll be able to use Git.
Pretty much, yeah. But most of these I use from time to time, and worth knowing about. So I think I want to see how many of those I can get through. Try to save 10 or 15 minutes at the end for more general questions people have. I think we're actually done with the display for right now. My second commit is lost there.
I had no idea that was a thing.
Yeah.
Awesome. Okay, question.
Yeah.
Does Git ever store the diffs, or does it restore, like, store completely new blocks?
Below this level, you kind of don't have to care. It does some clever things to not store the entire content of my C file more than once. You can think of it effectively as storing diffs, or storing entire files, or as storing diffs. Some operations treat them one way. It's obviously trivial to convert from one to the other.
So is there, how familiar are you with the format?
Not deeply.
I'm wondering if there's like instance frames of the file where it's like, okay, you shouldn't have to reconstruct this file from like 500 diffs, so we're just going to include a full copy of the file now.
Yeah.
Every once in a while. There are?
I don't know, but that's an interesting question. Okay. Yeah. Oh, this is off anyway. Okay. So we have these. Actually, we have these bunch of objects. Most of the time, we really care about manipulating commits directly. So we can condense this down and look at just the commits. So we had 8CE 4 was my first commit, and the second commit turned out to be 5C7D something something C7D, and this one points to this one as its parent. So that's a condensed version of what we had already over there. We actually have a few. That was a mess. That's better. We already have a few more things going on in the repository. We have a branch. In particular, we have a little label here that says master, and right now it's pointing to that commit. We have another pointer here that's spelled head, and that's pointing to master. So lots of commands operate on head, or direct on whatever commit head is eventually pointing to. And so, in reference to the index and the working tree, which I forgot to say is the name for this thing over here. Right. So in particular, let's see. In particular, we started off and master was here. Head was already pointing to master. I made a second commit. We got this new commit, and we said, what is head pointing to? Let's point it to the new commit. So commit updates what head points to. Sometimes head can point directly to a commit. That's not often useful, but then you just update head. So we've got two commits. We can add a new branch. So get branch. Let's give it the boring name of feature. Great, we've got a feature branch, and I didn't say what to point it to, so it's pointing to whatever head is pointing to, so it's pointing there too. I can say git checkout feature. And checkout, as distinct from its other mode in which it manipulates stuff in your working tree, that's completely independent. Here is going to change what head points to, so let me just redraw that. So checkout made head now point to feature, still eventually to the same commit. But this means if we make a new commit, 2, 3, 4, we're now going to update not master. This is going to have its parent there, not master, but feature. And we have our 2 branches pointing at 2 different places. Shorthand for this is, common shorthand for this is checkout -b. Does both of those together. We can commit some stuff. We can, let's say we check out master again. So we're there, and we make another commit. Now we've got new commit here. We have created 2 commits with the same parent, and we've moved master along to point there. 2 commits. We're on master. We can say git merge feature to say I want to add to master effectively all the changes that were introduced by these commits that are on feature but are not on master. So we're going to have a new thing here that contains, hopefully it's able to intelligently merge what you had in both of these commits. And we actually end up with a commit with 2 parents. So I'm building a nice little graph of commits. Yeah.
When a file is, let's say you try to restore a file to a previous version that you had, and I guess well, so Git keeps track of the commits that have made to that file, and if you want to jump the file back to like 2 commits ago, does it restore the file based on the diffs it has on that file?
So this is kind of back to what I was just talking about. You mostly don't have to care about whether it's diffs or full versions of the file. In the object sense here, it is full versions of the file, but it is more efficient than that underneath. Not sure. Okay, did I check off some things here? All right, we know branch, we know merge, we know one of the forms of checkout. The other one is not actually quite so interesting. The other one is give it a path name, and it will copy it from the index to the working tree, or from the head commit to the working tree, something like that. Yeah.
With the tree, once you merge, why don't you have it pointed to the most recent commit? Did we revert back to one? Did I miss something? Once you merge it back in, there's no like label or anything or head pointed to the most recent.
Because there are too many pointers and I can't keep them all straight. This is why we have computers.
Yeah. Okay, I just wondered.
Yes.
Wow.
Like
Yes.
when you did Git operations, you'd edit the Git files.
Oh, you
With
like
your
move the
operation.
pointers around?
Like Git commit was initially just an alias.
Yeah, there are still nice little plumbing commands. You can say, create me a tree, and now point the branch to the tree, and now update head to point to, yeah.
Git tutorials circa 2005. You put them up on the Wayback Machine, but it's all like, use all this shit to do these things. And then things that were super common that people probably made into aliases just became Git commands.
Yeah, so that's the larger picture of these commands, is they've very much evolved over time and evolved to do different things. So now we have checkout that can create branches, and checkout that can also reset your files. And there are tons of different ways to express the same thing. But I think this is a reasonably standard set of things people would use. What do I want to do now? We can say reset is a straightforward one to check off. Head is at master. Reset will move master back to wherever we want. So whatever head is pointing at, we can say git reset 5C7D, and now we're back here. And now we actually have no easy way to get to these commits, and that's why you go look in git reflog, which will tell you all the places that head used to point recently. Okay. We can do some other sort of manipulating history stuff. A bunch of these commands often get referred to as rewriting history. In a sense, they're not really. The object database is write only. You can create new objects. Can't modify these. That would change the hashes anyway. But you can do all sorts of fun stuff with the changes introduced by these commits and where the branches point and things like that. Except I also wanted to mention one more thing in here, which is, I don't think we got this over there, git tag. Git tag 1, and this is going to create us a nice little tag object. It's either going to create us a tag object or it's going to create us something that's just like a branch object and point somewhere. But this can have a message and things in it, and then it's going to point to a commit right here. So that's a nice way of giving a name to a commit, a version you've released or something like that. That's not intended to be moved around later like branches are. Okay, so rewriting history. Let's go, let's undo that merge. Git erase. And actually I wanted to check out feature again. Git checkout feature, working on feature. And we can say there are a bunch of things we can do with a rebase, but we can say in a fairly simple form, git rebase master. And here we will get a new commit with a new hash with this as its parent, but such that this arrow hopefully contains the same difference in code as this did. So we have sort of the same change introduced by this commit, but now its parent is actually that commit. And now feature points there. That's often nice to end up with a more linear flow of history instead of a complicated graph, but not strictly necessary to get changes you want. Yeah, you can construct commit graphs with branch and merge, and that's about it. Yeah. All right, so we got reset, we got rebase. We can let's undo that too. Because we can actually get a similar effect here by checking out master again and saying get cherry pick and then referring to a commit. We could use the branch name, which is feature. We could use the actual commit hash 234. some way to refer to this commit or a range of commits, whatever, and we're going to get very nearly the same thing we had before. We have a commit that has the same changes introduced by this commit. It's on top of master, except let's pretend master was here to begin with. And now master is pointing there.
So can you just like succinctly explain the difference between rebase master and like cherry pick master? What would be the difference?
For one thing, rebase.
Cherry pick what?
Cherry pick just moves the commit on the top to the branch that you're currently on. So you're getting one thing from another branch. Rebase jumps an entire branch onto another.
Right, so yeah, and it's also which branch you're referring to. Right, so cherry pick is, at least in this form, it can take a list of commits, but if you specify a branch name, you're just referring to the commit that branch is pointing to. You're going to pick that one commit and put it on your current branch. Rebase is going to take your current branch and take all the changes that it doesn't have in common with master and put those on top of master. Something like that. How am I doing? Rebase, tag. We had cherry pick in here, so I'm going to check that off already. Cool. All right, time is short. People have general questions about using Git that I can try to explain in this context. That's great. And also go on to trying to explain remote repositories and how the repositories communicate with each other or something like that. I don't see any questions. Okay. So I hope it makes sense.
Is there a way to visualize things written on a board and messing around with it, getting a feel for it?
Yes, let me, yeah. I'll get the projector back in a minute and do some of these sort of, it's a set of commands we have there that are just looking at what's in the repository.
What's the difference between reset and revert?
So reset I explained already, right? This is going to take the branch that head is pointing to and point it somewhere else. It's optionally going to also update your index in your working tree to match what it's pointing to, but there are various options for that. Revert is entirely different, actually. So let's say I'm a master now. I can say revert this commit. And this is going to actually add a new commit on here that master points to, such that the change this commit introduces is the opposite of the change this one introduced. So we undo the change by adding a new commit. Which is useful because if I have time to talk about it, when you're sharing repositories, people are a lot happier if and Git is a lot happier if your branches keep moving along to descendants of what they were pointing to before, and it progresses smoothly.
What's the best like situations to use Git RM?
So RM.
Because I was run into an issue where like I will Git RM a file rather than just regularly delete it and then commit the deletion with the change and then push back. Where other repositories end up still having the file, but then no longer tracking it.
Yeah. And as long as you get the change into a commit, it shouldn't matter how you got it there. But yeah, git rm is going to, let's see, it should remove the file from your working tree and from your index, so that when you go to commit, you're going to have a commit that says readme is no longer there. Hopefully then when other repositories get that, they're going to update to this state of the index with no README in it. Be gone. Okay, 10 minutes, remote repositories, something like that. Let me make this repository simpler, because I'm going to have to redraw it all over again. So I can be on a totally different machine here and say, ooh, the most straightforward way to get this set up is to say Git Clone. And there are a bunch of different things I could say here. Maybe it's on my local file system. To example, and there's my Git repository. Or maybe it's over, I can access it over HTTP, or there's a special little Git protocol for doing these things. Or maybe it's on a server that I can access with SSH. And beyond that, it doesn't really matter. So store your code on the Git repositories on the Unix servers works fine. And that will have a colon. And maybe I've created this one actually as a bare repository, which doesn't actually have a working tree associated with it. It's just useful as something to refer to remotely. This is the same pattern you see referring to GitHub repositories, same deal. So now we're going to get a new working tree over here. It's also going to be called example, but it's on my new machine, and it has my files in it, and it has my commits in it. E7F and 2, 3, 4, and it has sort of branches, but it has tracking branches, I believe, that that just follow whatever these branches over here do. So I have something that you can call origin/feature. That points here, and you have something origin/master that points here. In this particular case, it may be relevant that head here was pointing to master, but I'm going to end up with a local branch called master that is pointing to this commit as well, and that's where my own head is. Okay? And I can, maybe I made a new commit over here, 7.3b, and so master is here. I can say on this side, git fetch, and this will pull in the new commit and point origin master there. It's not going to update my local master. Maybe I'm working on that. I don't want that moved out from under me. But if I want to, well, I could use git reset to move this pointer along. I can also, a little nicer to do git merge. And merge, in fact, by default, if you're merging in something that's a descendant of your current commit, we don't actually have to create a new merge commit. We can just move it downstream there, and then we've got all the changes. These two together, more or less, let's git pull. So there are a few different places this can live, and config will read them and update them, or you can just update them yourself. There's a file under here called config. There's a file up in my home directory called .git config. And so repository-specific stuff can go there. All my general stuff can go there.
So that'll be updated with --local and --global.
I believe so. Yeah.
And then but there's nothing in /etc.
It will probably read etc git config if you have one. Man git.
It's like I can make edits to a global template with the root file system, but not the root file system. So yeah, it's good to figure but things globally.
I generally don't want to talk about Git settings globally though, because people are going to have specific needs about them, and if they have those things changed from under them by a global config, it's going to screw stuff up.
That's certainly true, but for a strictly one user system.
I still would do it, but it's your preference.
All right. The other thing I could have said there was git push, which is going to sort of go in the reverse direction and update the remote branches to match your local branches. But there are a few things I want to make sure I get to here. Documentation. We were just talking about config. We can man git config. In fact, maybe man is clever enough to do it space. And it will tell us about all the different ways you can configure Git, different options, and I think this man page actually tells you what all the different options are. Files, what was that? Etc git config. It'll look in xdg config home, that's pretty cool. It'll look in .git config, and it'll look in your own repository. I think you can also get this if you say git help config. You can also say git config -- help. You can say -- web, and maybe you've got the HTML pages installed, and it looks a little nicer. So those are all very useful. That's a slightly more useful command, maybe. To figure out how to use a command and all the different ways you can use it. That's about it on documentation. We were talking about some informational commands. Git status is very useful. That's kind of, let me edit my file again. Git status will tell me about how my working tree and index and commit all compare, and it'll say I've modified that file relative to index. If I add that file, it'll say now I've modified it in the index relative to the commit, and it calls this the staging area or something like that. Git log is going to show me, going to start at head and walk backwards and show me all the commits it found there. You can do some fun things with this. You can say git log. Actually, this is kind of boring here, but -- graph will draw a bunch of different branches and little lines between them. Can add one line, and now we've got a really compact view, and this is more exciting on larger repositories. Git show shows you an arbitrary object, but by default it's the commit that head points to, which looks like this. There's what I changed in that commit. Did I do diff already? No, because it's in the index, but if I say -- cached, it'll look at what's in the index relative to, anyway. I think we're about out of time. Final thoughts? Questions? No? All right. Thanks then.